So before we go too far into circular motion, let's make sure we understand some other terms which we hopefully would have seen earlier in our physics career. First one's frequency and period. So frequency is the number of events per unit time, where period is just the reciprocal of that, the time for one complete event. This tends to be for things that rotate very, very, very quickly, we more often use frequency, whereas slower rotating things we use period. So here is a question. It says, what is the frequency and period of a wheel of a car that is revolving 980 times in 40 seconds? So for this one, we say, okay, if we want frequency, it's going to be like the stuff, so number of events in per unit time. Okay. So that is going to be saying, oh, it's 980 things, in this case revolutions, occurred in 40.0 seconds. So we just divide those two numbers, we get 24.5 hertz. So hertz is the unit for frequency. Hertz is also equal to 1/second. So it's stuff per second, stuff per time. Period, on the other hand, is just the reciprocal of that. So 1/f. And we get a value of 0. So 1 divided by 24.5, we get 0.408 seconds. And this next question says, the moon's nearly circular orbit about the Earth has a radius of about 384,000 kilometers in a period of 27.3 days. Determine its orbital speed and its acceleration toward the Earth. Okay, so for this one, we're going to write down V is equal to, so when you're traveling around a circle, the circumference of the circle, so V is equal to distance over time, but the distance in a circular path is the circumference, so 2 pi r over t. So in this case, I'm going to write down capital T, because capital T stands for period, whereas little t just stands for general time. So I have 2 pi, and our radius is 384,000 kilometers, but I need to add 3 extra zeros because I need to have my SI units, which are meters. And for time, 27.3 days, but again, we need SI units for time, so I'm going to take 27.3. There are 24 hours in one day, and there's 3,600 seconds in each hour, so we get a time of 2,358,720 seconds. Divide those together and we get 1.02 times 10 to the 3 meters per second. So it's traveling around a kilometer every second. That's how fast our moon is traveling. For acceleration, AC is equal to V squared over R. Just plug in that speed, 1.02 times 10 to the 3 meters per second. We're going to square that number, and we're going to divide it by a radius, so 3.84 times 10 to the 8. Again, we need meters, not in kilometers. And we get 2.72 times 10 to the negative 3 meters per second squared. So the acceleration is pretty small, but because it's so massive, these objects, the overall force would actually be pretty big. Note, if we want to actually go directly and solve for acceleration, we can also use our other equation for acceleration, V squared over R. But if we just did a little bit of algebra, plug in the 2 pi r over t, this comes out to be 4 pi squared r over t squared. So we could just plug directly into that to get our acceleration. But we instead solve for velocity first. Both are great, but it doesn't matter.